So in 2020, we revised some of the worksheets, which is a whole reason why I have to do a new set of notes and a new video. 10.8 is on the average rate of change. What they want you to realize in this unit is that for parabolas, where it changes, the slope changes as we go along the parabola. Think about this. The slope is 0, and the slope might be, the average rate of change might be like a 1, and then as you start going up, the slope changes. It gets steeper and steeper and steeper as you move alongside of that parabola. That's what we're going to be talking about, this rate of change. How much it changes by is basically a measure of how steep the incline or how steep the decline is. What we're going to be doing, the math behind it, is really we're going to be finding the average rate of change. And this is where I say we're going to be talking about 2 points on the parabola. I don't know what they are, or 2 points along anything, and we're going to find the average between those 2 points. Now, one thing I do like to talk about, just because it is impossible for a Math 2 or a Math 3 students to figure out what the rate of change is at a single point. It's not until you get to calculus upon which you are able to figure out what the instantaneous rate of change is, which is a calculus topic. And if you've ever wondered, what do they learn about in that book, calculus? They don't talk about averages anymore. They talk about instantaneous, what's happening at that exact moment in time. It's kind of a neat thing. Instead of just doing an average, you use something called a derivative. It's really kind of neat how you can apply math to this kind of stuff. The average rate of change that we're going to do the y's subtracted by each other divided by the x's subtracted by each other. This little y2 minus y1, you've seen it in Math 1. x2 minus x1, these 2's and 1's just basically means this x is different than this x. This is your second y subtracted by your first y. This is your second x subtracted by your first x. You got to do that first, divide, and that's what your slope is. That will give you the average rate. How far up did we go divided by how far over did you go? Now, I show it to you this way, but you should also be able to think of it as output minus output divided by input minus input, because there's going to be a few problems. There's going to be a few problems on your worksheet where you have to figure out what is the output. If you're only given the input, sometimes you're going to have to plug in each input into the function to figure out what is the output. You'll see what I mean in just a second. So here are the examples that I picked for you. I think you have this in your notes. I think you have 1, 2, and 3. But I do not think that you have this in your notes until you turn the page. So let's talk about 1, 2, and 3, and then we'll go from there. A toy car is traveling up an inclined plane. The graph shows the distance the car has traveled at t seconds. Use the graph to answer the questions. At 1 second, how far is the distance do you think this car has traveled? Let's look at this graph a little bit. 1 second, how far has the car traveled? What do you think that number is?
5.
I agree. I think it's 5. 5 what? 5?
5
No, oh wait.
centimeters.
It's right there, centimeters. We got to find 3 seconds and we got to find 5 seconds. So at 3 seconds, what do you think it's at? And what about at 5 seconds? Okay. So you said 13 and 17? That's our answers to 1A, B, and C. Now what they're asking us to find is the average rate of change from 1 second to 3 seconds. How much did it change by? This is your distance, this is your output, this is your input. If you don't know, we're going to take this output, 13 centimeters Take away 5 centimeters. Think of this as your Y2, and this is your Y1. This is your X2. This is your X1. That's what I mean by output and input. At this many seconds, it went this far. So we're going to subtract the second Y from the first Y, and we're going to divide that by 3 seconds. Take away 1 second. That's what our average rate is. So what do? 13 centimeters minus 5 centimeters is 8 centimeters. 3 seconds minus 1 second is 2 seconds. Well, that can simplify. 8 divided by 2 is 4. And look at what the units are. Centimeters per second. What that tells you is this toy car is traveling from 1 second to 3 seconds. It is traveling an average of 4 centimeters per second. And we're basing that off of the distance it traveled. It traveled this far at this time, this far at this time, this far at this time. We can figure out what the average centimeters per second it is traveling. But like I said, it's not until calculus upon which you can find how fast is it actually traveling at that moment in time. Well, you can only find averages in Math 2 and Math 3. It's kind of a neat thing. Well, that was the average from 1 to 3. What about from 3 to 5? We're going to have to change some things. This one will be our third Y and our third X. Let's do Y3 minus Y2 over X3 minus X2, meaning like this Y minus that one. Let's do 17 centimeters minus 13 centimeters over 5 seconds minus 3 seconds. Let's find out what that average is. How about 4 centimeters over 2 seconds? Reduce. Now think about that answer, because your very, very next question is going to say from 1 second to 3 seconds, it's going 4 centimeters per second. At 3 seconds to 5 seconds, it's going at 2 centimeters per second. You've ridden in a car before. So if you were going this many miles per hour and then this many miles per hour and it's going smaller, what's happening to that car? What's happening to that car? Slowing down. Why? It's going uphill. It's going up an inclined plane, so it's slowing down as it goes. It doesn't travel as far. Kind of a neat idea. That's what you're going to have to answer in your worksheet. Sometimes you're going to have to use a graph, but most of the time you're going to have to actually figure out what the outputs are. Like this number. This is number 5A in my notes. You're going to have to turn your page. Oh, look, it's right there. You just turn your page and there you go. F of x is x squared. G of x is 2 to the x. And what this says is, what's your average rate of change of f of x from 1 to 3, and what's your average rate of change from g of x from 1 to 3? Well, you don't have your chart, so you have to fill it in. That's why I adjusted this sentence right here. This sentence says, you're only given the input, calculate the output by plugging in each input into the function. What does that mean? That means this. Even though you're given 1 for x, you're going to have to plug that in here and put 1 squared. What do you get when you get 1 squared? What happens when you put the 2 in and you get 2 squared? What does that simplify to? What is 2 squared? Yes, 4. 2 times 2. What happens when you plug in the 3 and get 3 squared? What does that simplify to? You're getting better. 4 squared is? And 5 squared. So these are your outputs. These are your y's. These are your x's. When you're looking for your average rate of change, you actually have to calculate or figure out what the output is by plugging it into the function. This says g of x. We're not using f of x. We're not using this function. We're using the function that is named by the g. You can think of this as the Fred function, and this is the Gina function. And we're now plugging in 1 into Gina's function. Whoa. 2 to the first power. We're plugging the 1. I was naming the function. I'm sorry. My brain sometimes goes off on tangents, so I had to recorrect my brain. 2 to the first is 2. 2, if we plug the 2 in where that x is, 2 to the second is it looks almost similar, but it's not. 2 to the third power means 2 times 2 times 2. 2 to the fourth power means 2 times 2 times 2 times 2. And you can start seeing the pattern. 2 to the fifth power is... So the first thing we have to do is figure out what goes in the boxes, which is what we just did. The second thing that we have to do is we have to find the average rate of change of f of x from 1 to 3. Well, that means that you're going to be using the first box. You need the y values that goes with the 3 and the y values that go with the 1. The x's are on bottom. The y's are on top. So for x is 3, I go over here and I see that the output is 9. For x is 1, the output is 1. We subtract the y's, we subtract the outputs, and divide it by the inputs subtracted by each other. So 9 minus 1 is 8, 3 minus 1 is 2, and you simplify it. The average rate of change from 1 to 3 is 4. The average rate of change on the other function, we'll still do 3 minus 1 as our x, this x minus that x. So let's go to the outputs now. I go for the 3. What's the y output? Keep those lined up. The 1 has an output of 2. Keep those lined up. And let's simplify 8 minus 2 over 3 minus 1. Now I want to ask you a question, which is, the average rates of change are different. What does it mean in relationship to the graphs? This slope is 4. This slope is 3. Which function is steeper? Which function has a greater slope? You should be saying either f of x or g of x. F of x. Because this is higher. It has a higher rate of change than 3. This one goes up 4 over 1. This one goes up 3 over 1. Think about it. It is steeper. So when it says the average rate of change are different, what does this mean in relationship to the graph? F of x is steeper than g of x. And we're talking about from 1 to 3. That might change somewhere else along the graph, but we know by our math that it's steeper there. The first thing you have to know is how to be able to go from a picture and be able to write down points and then find the average rate of change. The second thing you have to be able to do is plug in things into a table to find the average rate of change. And the last thing you have to do to find average rate of change is, if they don't give you any tables, if they don't give you any pictures, what if they just give you the problem? Here's your function. This is number 10. I don't know where it is on your paper. You're going to have to look for it. It might be number 10 on your paper somewhere, or it might be on the second column. Do you see anything there that says given? Yep, let's go to the next. Nope, let's go one more page up and see. Nope. It'll be on the worksheet somewhere, okay? So just watch if you don't have it to write it down. Find the average rate of change from 1 to 4. This is your x1. This is your x2. If they only give you an input, how do you find the output? You have to plug that in. 3 to the first is what? That's your output. 3 to the fourth power. It means 3 times 3 times 3 times 3. If you don't know how to do that, just do these two and do 9 and 9. What's 9 times 9?
81.
This is your second y. This is your output when x is 4, y is 81. When x is 1, y is 3. So now we can find the average rate of change. Take your second y, 81, and subtract by your first y over your second x minus your first x. 81, that's really hard to read, so I'm sorry. Let me fix that. 81 minus 3 over 4 minus 1. 81 minus 3. 78 over 3. I must be getting lazy because I'm going to the calculator. Oh, there we go. 26. The average rate of change is 26 units from 1 to 4. That's where I'm going to stop your notes.